So in this video, we're going to go over topics that would have been covered in Science 10. And the first topic that we're going to go over is what a mole is. Okay, so a mole is just a word that refers to a specific number of molecules. Just like when we talk about a dozen of eggs, we refer to specifically 12 eggs. Okay, or a dozen of any object is going to refer to 12 of whatever object that you're talking about. So similarly, a mole of molecules specifically refers to 6.02 times 10 to the power of 23 molecules. Now, this number is called Avogadro's number. So Avogadro is a scientist. Now, a mole of molecules is an amount that a person can hold in a beaker or weigh on a balance easily. And the reason why 6.02 times 10 to the power of 23 molecules was chosen is because the number of grams in the mass of 1 mole of atoms of any element is going to be equal to the atomic weight of whatever element that you're talking about. Okay, so for example, 1 mole of mercury atoms not only contains 6.02 times 10 to the power of 23 atoms, but its mass is going to be equal to 200.59. So if we look at mercury's molar mass, which is going to be right here. So as I said, 1 mole of mercury atoms, the mass of that is going to be 200.59 grams, which is equal to mercury's molar mass, which is this number right here. Okay, so that's why we need to use, or that's the reason behind scientists choosing 6.02 times 10 to the power of 23 molecules to equal 1 mole. Okay, so in order to calculate the molar mass of a compound, what you have to do is you need to add up the molar masses of each atom in the formula. So for example, we need to find the molar mass of iron 3 sulfate. So remember that these Roman numerals, they refer to the charge of whatever ion comes in front of them. It does not refer to how many iron atoms or ions there are. Okay, so the first thing you need to do to figure out molar mass is you need to figure out, okay, what is the chemical formula for the substance you're trying to figure out the molar mass for. So iron, and it has a 3+ charge. And then sulfate is SO4. So sulfate, because it ends in ATE, that's one of our polyatomic ions that you can find in your list of polyatomic ions. So where you would find it is right here. Okay. Now, since sulfate has a 2- charge, I'm going to write that out, and since this doesn't equal 0, we need to do the crisscross applesauce. Okay, so I'm going to take the 3, put it behind sulfate, and then take the 2, put it behind iron. So now what we have is we have 2 times 3 from the iron, okay, and then we have 3 times -2. Well, 2 times +3 is 6. 3 times -2 is -6, which does equal 0. So this is now balanced. Okay, and now that we have the chemical formula for our compound, now we can figure out molar mass. And what I like to do to start students off with helping them figure out how to calculate molar mass is I like to start students off by building a table to just organize for them how to find it. So first we're going to break up the substance into each element that makes it up. Okay, and then the molar mass which I'm going to abbreviate to capital M, of each of those elements. We'll need to know how many atoms of each element we have, and then we'll have a totals column. Okay, so looking at my chemical formula over here, we have iron, we have sulfur, and we have oxygen. Okay, so for iron, the molar mass of iron, let's find that, is going to be 55.85. And there are 2 atoms of it. Okay, and what we're going to be doing with these numbers is we're going to be multiplying them. So 2 times 55.85 is going to give us 111.7. And then we're going to do the same process with sulfur. So finding sulfur on our table, the molar mass for it is 32.07. And if we look, so because sulfate, we indicated that there had to be 3 sulfate ions in order to balance the charge of the iron 3+. So you need to know that this 3 applies to everything inside the brackets. So we have 3 sulfurs and 12 oxygens here. So 32.07 times by 3 is going to give us 96.21. With oxygen, the molar mass for that is going to be 16. Okay, and as I said, it's going to be 12 atoms of oxygen because we're going 4 times 3. Okay, so 16 times 12 is going to give us 192.0. Okay, and now what we're going to do to all of these numbers in our total column is we're going to add them up. So that's going to give us 399.91 grams per 1 mole. Okay, so grams per mole, that is the units for molar mass. Okay, it's always going to be grams per 1 mole. All right, so moving on to some more examples. So here we have H₂SO₄. So let's do the same table here. So we got our elements, molar mass, atoms, and then our totals. Okay, so we have hydrogen, sulfur, and oxygen. So hydrogen, the molar mass for that is 1.01. For sulfur, it's going to be 32.07. For oxygen, it's 16. So we have 2 atoms of hydrogen, we have 1 atom of sulfur, and 4 atoms of oxygen. So let's multiply these molar masses with the amount of atoms for each element. So 1.01 times 2, 2.02. And then for sulfur, that's just going to be 32.07. And then 16 times 4 is going to give us 64. Adding that all up, and we get 98.09 grams per mole. Okay, so molar mass for H₂SO₄ is going to be 98.09. Okay, if you're curious about the name of this substance, that's going to be sulfuric acid. We haven't gone over the naming convention for acids yet. We'll get into that in a later unit. Okay. Now, 1 mole of sulfuric acid, based off of the fact that we know that Avogadro's number is the number of grams in the mass of 1 mole of atoms of any element. So what that means is 1 mole of sulfuric acid is going to be 98.09 grams. And 1 mole of sulfuric acid is going to contain 6.02 times 10 to the power of 23 molecules. Okay. Now, with carbon dioxide, let's figure out the molar mass here. So I'll do that chart again. Let's see if I have enough room for it. Okay, so we have carbon, we have oxygen. The molar mass of carbon is going to be 12.01. Molar mass of oxygen is going to be 16. We have 1 atom of carbon and 2 atoms of oxygen. So multiplying the molar mass with the amount of atoms. So for carbon, it's just going to be 12.01. And then for oxygen, that's going to be 32. And adding those up, we're going to get 44.01 grams per mole. So the molar mass of carbon dioxide, that's what we just figured out, 44.01 grams per mole. And 44.01 grams of carbon dioxide is going to be equivalent to 1 mole. And 1 mole of carbon dioxide is going to contain let's get rid of that dot there, 6.02 times 10 to the power of 23 molecules. Okay. So with this next section here, it's just getting at the fact that the 6.02 times 10 to the power of 23, that is an insanely huge number. And to help you visualize how big that number is, let's look at these examples here. So 1 mole of marbles, so that would be 6.02 times 10 to the power of 23 marbles. That would cover the entire Earth, with the oceans included, for a depth of 3 miles. Okay? Or alternatively, 1 mole of $100 bills stacked one on top of another would reach from the sun to Pluto and back 7.5 million times. Okay? And last but not least, it would take light 9,500 years to travel from the bottom to the top of a stack of 1 moles of $1 bills. So hopefully that can give you a sense of just how big Avogadro's number is, which is at 6.02 times 10 to the power of 23. Okay. However, since atoms are so small, 1 mole, so 6.02 times 10 to the power of 23 molecules of carbon atoms is going to equal just 12.01 grams. Okay, so that's another reason why we have to use such a big number to represent a mole. It's just because atoms are just so tiny. So now we're going to get into more calculations, and for the next couple of sections here, we're going to be finding mass from moles and molar mass, and then finding moles from mass and molar mass. Okay. And what I'll do here is, first I'll give you the formula in case you want to use it, but I'll also be talking about unit analysis, which this book calls dimensional analysis. They mean the same thing. Okay, so using units to solve problems involving mass, molar mass, and moles. So step 1 is going to be determine what you're given and what you're asked to find. Step 2, think of something that has both the units you have and what you're looking for. Step 3, flip some units if necessary so that you can cancel out the ones that you don't need and end up with the ones that you're looking for. So step 3 is based off of if you have the same unit in the numerator and denominator, they're going to cancel out. Okay, so this is important for figuring out the basics of unit analysis. Okay, so for this first example here, we're asked to find the mass, so mass is equal to question mark, of a 0.960 mole sample of HCl or hydrochloric acid, which we haven't gotten into naming acids just yet, but that's what you'd call that, hydrochloric acid or hydrogen chloride. Okay, so moles, the symbol for moles is N. So we had 0.960 moles. Okay, and in order to figure out the mass, we're going to need molar mass. Okay, so for molar mass, we know that, so because there's limited space here, I'm not going to be able to do the chart. Okay, but we have our molar mass for hydrogen is 1.01. There's only one of them. Okay, so 1.01 times 1 is still 1.01. And then the molar mass for chlorine is going to be 35.45. And there's only one of them, so 1 times 35.45 is still the same number. Okay, now if we add those up, we're going to get 36.46 grams per mole. So that's our molar mass of hydrochloric acid. So let's write that in our list of givens. Okay, so for this example, I will give you the formula just in case you want to use it, but in the next 2 examples, I will be focusing on unit analysis just to give you some options as to how you can solve problems. Okay, so the formula for this is mass is equal to moles times by molar mass. Okay, so little m is mass, N is moles, and then capital M is molar mass. Okay, so now that we have our list of givens and our formula, I'm just going to plug in my numbers and then multiply the two. So 0.960 moles, and I recommend writing down the units here, just so you can see how they cancel out. So it's a nice kind of segue into unit analysis. Okay, so just looking at the units here, I notice that I have moles on the top and the bottom. So those are going to cancel out. And what I'm left with is grams. Okay, so if I multiply these 2 numbers, what I'm going to get is 35.001 grams. But for every calculation from here on out, we're going to be needing to take sig digs into account. So for sig digs, you look at whatever numbers that you're given and figure out, okay, how many sig digs are given to me, and you always go with the number with the least amount of sig digs. So especially if you're multiplying or dividing here. So looking at this number here, we have 1, 2, 3 sig digs. So remember, leading zeros do not count as sig digs. So I'm going to write 3 sig digs. And then if I count from the left, so 1, 2, 3, my cutoff line is right there. So my final answer is going to be 35.0 grams. All right, so for this example here, I'm going to be using unit analysis here. You can choose whether you want to use formulas or use unit analysis, but For both, you will need to write out the units and show how they cancel, because what I find students often do when they don't write the units is they can number crunch just fine in their calculators, but they end up having no clue what their units are in the end. Okay? So if you write out your units, you'll see how they cancel out, and you'll never be lost as to what units you're going to have in your final answer. Okay, so we're asked to find the mass. So little m, we have no clue. Okay, of 4.5 moles. So moles is going to be 4.5 of carbon dioxide. Okay, so carbon dioxide, that's going to be CO₂. Okay, carbon has a molar mass of 12.01. Oxygen, each oxygen atom has a molar mass of 16. Since there's two of them, 16 times 2, that's going to be 32. So 12.01 plus 32, that's going to give us 44.01 grams per mole. So that's our molar mass. So whenever you're given the identity of a substance, you're secretly given the molar mass. Okay, and you just need to put in a little extra work to figure it out. All right. So what I'd recommend doing is write the value that doesn't have fractional units. Write that one first. Okay, so I'm going to write the moles first because there's not a fraction in the units there. So 4.5 moles. Okay, so since we know mass is usually in grams, whenever the question doesn't specify what they want for units for mass, they want it in grams. So we're starting off with moles. We need to get to grams. So that means we need to cancel out moles and then get our final answer in grams. So if moles is on the top, okay, based off of the principle of if you have the exact same thing on the top and the bottom, they will cancel out. So I'm going to put moles in the bottom. Okay, and then since we want grams, and that's going to be a unit that you want in the numerator, I'm going to put grams there. So then that's still going to use molar mass. Okay, and wherever the grams go, the value for molar mass is going to go there. Okay, so moles, it's on the top and the bottom, so they cancel out. If it really bugs you to not have a number here, you can put 1 mole, because molar mass is always however many grams per 1 mole. Okay, and if we look at when we were using our formula, we're doing the exact same thing. We're taking moles and we're multiplying it by molar mass. Okay. Okay, so if we multiply those two numbers together, what we're going to get is 198.045 grams. And then the number we were given has 2 sig digs in it, so my answer needs to be in 2 sig digs. Okay, so if I start counting from the far left-hand side, 1, 2, there's my cutoff line. Now, if your cutoff line comes before the decimal, you're going to need to use scientific notation in order to represent that number. Okay, so I'm going to go 1, 2. So I'm moving the decimal over 2 to the left, because in scientific notation you can only ever have one digit that's not 0 to the left of the decimal. So 1 point, and I'm gonna round off in a second here. Okay, so times 10 to the power of, this is going to be positive 2 because our original number was greater than 1. Okay, oop. But for sig digs here, my cutoff line is still there. Okay, so since the number right after the cutoff line is higher than 5, or even if it's 5 and higher, it's going to round up the number in front of the cutoff line. But since this number is a 9, it's also going to bump up the next digit to the left. So this is going to be 2.0 times 10 to the power of 2, and our units are grams. All right, last but not least, how many grams, so they're asking for mass, make up 1.45 times 10 to the power of negative 3 moles of hydrogen peroxide. So mass, we have no clue. Moles is 1.45 times 10 to the power of negative 3 moles. And then we need to figure out our molar mass. Okay, so hydrogen peroxide is going to be H₂SO₂. All right, so with that, okay, hydrogen, there's 2 of them. 2 times 1.01 is going to be 2.02, plus oxygen, molar mass for that is 16. 16 times 2 is 32. Add those up together, and we are going to get 34.02 grams per mole. Okay, so I'm going to do unit analysis again. So first I'm going to write off the number that doesn't have fractional units. So 1.45 times 10 to the power of negative 3. Okay, times by, and then fraction sign. So whenever you're doing unit analysis, you always do this times by and then fraction sign. Oh, and then I need to write my units. Okay, so I want to cancel out moles and be left with grams. So moles is on the top. I need to put moles on the bottom, and then grams goes on top. Okay, so our molar mass. So how I know to put molar mass there is because the units are grams per mole, which match up with my units for molar mass. So 34.02. So moles cancels out. And when I multiply those two numbers together, I get 0.049329 grams. Okay, so then got to look at my number, and for the sig digs given, it's going to be like you count the digits that are in front of the times 10 to the power of whatever exponent. Okay, those are where your sig digs are coming from. So this has 3 sig digs. The reason why we never use molar mass for sig digs is because it's a constant, and you never use constants to determine sig digs. Okay, so 3 sig digs. So I count 1, 2, 3. So remember, these don't count. These zeros don't count because they're leading zeros. So then my cutoff line is right there. So if your cutoff line comes after the decimal, you don't necessarily have to use scientific notation, but you could if you really wanted to. Okay, so 0.0493 grams, or if you wanted to use scientific notation, what that would look like is we'd have to move our decimal 2 to the right. So then that would be 4.93 times 10 to the power of negative 2. The exponent's negative because our number was between 0 and 1. And our units, grams. So either or is fine for this case because both numbers have 3 significant digits in them. Okay, so part 2, finding moles. So what this is going to use, it's going to use the same formula that we used for finding mass, but just rearranged a little bit. So our formula for finding mass was mass is equal to moles times molar mass. Now, as a quick review as to how to rearrange equations there, what I like to do is just circle what I'm trying to find. And since this section is all about finding moles, that's how I know I want to find moles. Okay, so the next step you need to ask yourself, or the next question you need to ask yourself is, what is preventing moles from being by itself on one side? So I'm going to say, well, molar mass is getting in the way of moles being by itself. And then I'm going to ask myself, okay, well, what is molar mass doing to the moles? Well, it's multiplying. What's the opposite of multiplying? Well, that's going to be dividing. So I need to divide both sides by molar mass. Not moles, because that'll just move moles over to the other side, which defeats the purpose of trying to isolate moles, because that's not going to isolate moles if we divide by moles. Okay, so then what happens is molar mass cancels out, and if I write this all nice, neat, and pretty, we have mass divided by molar mass is equal to moles. So that is going to be the formula that we will use for these questions when we are not doing unit analysis. All right, so how many moles of hydrochloric acid, so that's HCl, make up a 35-gram sample? So writing out our list of givens. So we were given mass, that's 35.0 grams. Okay, we were given molar mass. So molar mass of HCl, we've calculated that previously. Okay, so we figured that out, that was 36.46. So I'm going to use that. And that's grams per mole. And since it says how many moles, that's how you know moles is a question mark. Okay, so using this formula, I'm going to go mass divided by molar mass is equal to moles. So you always start out with your list of givens and then your formula, and then you plug in your numbers. So 35.0 divided by 36.46, so that's grams per mole. It's equal to moles. Okay, so if you're wondering how the units cancel out here, let's see if I can write this off to the side. This will get demonstrated again when we use unit analysis. Okay, but if you wanted to know right now how the units are going to work out, so I'm just going to pay attention to units. I'm not writing the numbers here. So we have grams divided by, because I'm just taking this divide by sign and changing it into this divide by sign, just to make life easier, grams per mole. Now, how do we deal with dividing by fractions? Well, we flip this into a multiply sign, and then we flip the fraction that comes after it. So grams times moles per gram. Grams is on the top and the bottom. They cancel out. You're left with moles. Okay, so that's why I can go grams cancels out. And then 35 divided by 36.46, that's going to give us 0.9595 ... So this ... means that the number keeps on going, but it's not necessary to always write out the full number. It gets a little bit tiring writing out all the digits to all the numbers here, so that's why I write the ... Okay, moles is equal to N. All right, so this value that we were given, that has 3 significant digits in it. So I'm going to want to put this to 3 sig digs. So then I count 1, 2, 3. There's my cutoff line. This 0 does not count as a significant digit because it's a leading 0. So then this is going to turn into 0. So because this number right after the cutoff line is a 5, that's going to round up the number in front of it. But since the number in front of the cutoff line is a 9, that's also going to round up the next digit in front of that. So it's going to be 960. So we need this 0 to keep the 3 sig digs. And that's moles. Okay, so that's the formula way of doing these calculations. Now I'll move on to unit analysis. All right, so how many moles? So N, we have no clue, are in 24.5 grams of sodium hydroxide. So mass is equal to 24.5 grams. And then for molar mass. Okay, so molar mass, sodium is going to be 22.99 plus oxygen is 16 plus hydrogen is going to be 1.01. Okay, so all of that added up together is going to give us 40 grams per mole. All right, so we always write the number that does not have the fractional units. So I'm going to write the 24.5 grams. Okay, and since we want to know how many moles that are in this mass of sodium hydroxide, that means I need to, first of all, cancel out grams and then get left with moles. So times by fraction sign, grams is on the top, so I'm going to put it on the bottom, and then I need to be left with moles. Okay, and then the 40 is going to be going where the grams goes. Okay, and again, if it really bugs you to not have a value there for moles, you can put 1. Okay, so what we're doing here, okay, even though it looks a little bit different than the previous question, we are doing the same thing mathematically. Okay, so I'll just break this down a little bit here. Okay, so for multiplying fractions, I would recommend turning your first number into a fraction, but in a way that does not change the value of that number. So what you can do is go divide by 1, because anything divided by 1 is still going to be the same number. All right, so 24.5 times by 1, that's going to be 24.5. Okay, and then 1 times 40, well, that's going to be 40. Now I'm going to deal with the units, so if grams is on the top and the bottom, they cancel out. We are left with moles, and now we have 24.5 divided by 40. Or in other words, our mass divided by our molar mass, which is what we did with the formula. Okay, so those two numbers divided are going to give us 0.6125 moles. And we're going to need it in 3 sigdigs. So 3 sigdigs. So remember, significant digits apply to any calculation. So starting from the far left, that doesn't count as a sigdig. 1, 2, 3, there's my cutoff line. So this is going to be 0.613 moles. All right, last example here. How many moles, so that tells us we're looking for moles, are there in 0.5 kilograms? So our mass is in kilograms, which is important to note, of calcium carbonate. So calcium carbonate, the symbol for calcium is Ca. For carbonate, since it ends in ATE, that's your giveaway that it's one of your polyatomic ions. So it's CO3 2-. Now, since calcium likes to have a 2+ charge and carbonate likes to have a 2- charge, that does equal 0, so we don't need to do any crisscross applesauce sort of situation here. Okay, now, since I know I'm going to need molar mass here, the molar mass for calcium is going to be 40.08, so you can look that up on the periodic table, plus molar mass for carbon is 12.01, plus molar mass for oxygen is 16. 16 times 3 is going to be 48. So then all of those numbers added up together, that's going to give us molar mass is equal to 100.09 grams per mole. Okay, so looking at our list of givens here, you may notice a problem. Our units of mass and the mass units in our molar mass, they are not the same. So in order for things to work out in this calculation, we need to make them the same. And that means we need to convert one of these units to be the same as the units of the other value. Now, I always recommend convert the units of the value that does not have fractional units. So what does that mean? That means convert your mass units from kilograms to grams. Okay, so let's see, I'll have to put it down here. So recalling your metric conversion line, okay, I'm just going to do the first half because that's all we need here. Okay, so our base units, that's where grams would be, and then kilograms would be right here. Okay, so if I'm going from kilograms to grams, okay, and how I know I want grams is because of the molar mass units there. So I start off at kilograms, count 1, 2, 3, so this means I need to move this decimal for mass 3 to the right. 1, 2, 3. So that's going to give me 500 grams. Or in other words, 0.5 kilograms is equal to 500 grams. Okay, so now that we have same units for mass, we can keep on going. All right, so start off with non-fractional units times by fraction sign. I need to cancel out grams. Grams is on the top, so I put it on the bottom. I want to be left with moles because the question asks, how many moles? Okay, my molar mass was 100.09. 1 mole. Okay, so grams on the top and the bottom, they cancel out. 500 times 1 is going to be 500. 1 times 100.09 is going to be 100.09. Okay, 500 divided by 100.09, that's going to give us 4.9955 ... So when I'm not writing the full number, usually what I do is I write the first 4 digits and then go ... Okay, so there's 3 sigdigs in this number because the leading 0 doesn't count, but 1, 2, 3, these do count. So 1, 2, 3, there's my cutoff line, and this is going to round off to 5.00 moles.